So here in this problem, we have a condition that is a plus b plus c equals to pi radian. We need to verify that sine squared a over 2 plus sine squared b over 2 plus sine squared c over 2 that equals to 1 minus 2 times the product of sine a over 2, sine b over 2 and sine c over 2. So this is a problem of conditional trig identity. So let us begin our proof by starting from the left hand side. So on the left hand side we have sine squared a over 2 added to sine squared b over 2 added to sine squared c over 2. So here we're going to approach this problem by taking help of an identity which is given by cosine squared alpha minus sine squared beta. This is simply the product of two cosine function given by cosine of alpha plus beta multiplied to cosine of alpha minus beta. Fine. Okay. So here what we'll do, in order to convert, but we only have a sine function here. We do not have a cosine function. So what we'll do, we'll take the first term sine squared a over 2 and convert it to a equivalent cosine function. That's a very simple task because we know that cosine squared theta plus sine squared theta always equals to 1. So what we'll do, we can convert sine squared theta and write in terms of cosine squared theta as 1 minus cosine squared theta. Okay, fine. So sine squared a over 2, that is going to become 1 minus cosine squared a over 2. Added to, we're going to keep the second and the third term intact. So we have sine squared b over 2 added to sine squared c over 2. Okay, so now what we have 1. We're going to combine the second and the third term by taking negative as the common factor, such that we have negative times cosine squared a over 2 minus sine squared b over 2 added to sine squared c over 2. Now we apply this formula. This is going to give us 1 minus, we have cosine of the sum of the two angles. So we get a plus b over 2 multiplied to cosine times the difference of the two angles. We have a minus b over 2 added to sine squared c over 2. Next what we'll do, we're going to change cosine of a plus b over 2. So here let's make use of the fact that since a plus b plus c equals to pi radian, so a plus b is the same as pi minus c, means the same thing. But what we'll do, we'll divide both sides by 2 to get a plus b over 2 equals to pi over 2 minus c over 2. Now we take the cosine function of both sides. The cosine of a plus b divided by 2. This must be equals to cosine of pi over 2 minus c over 2. But we know that cosine of pi over 2 minus c over 2, this is simply sine c over 2. So essentially what it means is that cosine of a plus b over 2, this is the same as cosine sine of c over 2, provided we meet the criterion that a plus b plus c equals to pi radian. So now what we have is 1 minus. So instead of cosine of a plus b over 2, we're going to replace with sine c over 2 multiplied to cosine of the angle a minus b divided by 2 added to sine squared c over 2. Fine. So now what we have here is 1. So here we need a negative sign here. So what we'll do, we're going to take negative sine c over 2 as the common factor. We also need sine c over 2. So that means this is going to get multiplied to cosine of a minus b over 2 minus sine of c over 2, since we have taken negative as the common factor. Now we have 1 minus sine c over 2 multiplied to cosine of a minus b over 2. Now as we can see here, we have a cosine function and we have a sine function. In order to combine this, we need both of them to be cosine or both of them to be sine. But what we can do here, we can easily convert sine c over 2 to cosine of a plus b. We've already done that. So in place of sine c over 2, we're replacing with it cosine a plus b over 2. And in doing so, what we have found here, that we here get the difference of two cosine function. The difference of two cosine function means if we have cosine of alpha minus cosine of beta, this is going to be 2 times sine of the angle beta plus alpha over 2 times sine of beta minus alpha over 2. So here we will consider a minus b over 2 to be equivalent to beta and a plus b over 2 to be equivalent to beta. and that is going to give us 1 minus sine c over 2 multiplied to 2 times sine. So you can check that they are going to get a over 2 times sine of b over 2. So finally what we get is 1 minus 2 times the product of sine a over 2 times sine b over 2 times sine c over 2, which is exactly the expression on the right hand side. So let's verify it once more. So we needed 1 minus 2 times the product of sine a over 2, sine b over 2 and sine c over 2, and that's exactly what we have obtained. So we can finally say that thus the left hand side equals to the right hand side, hence proved.